genetics in real time when the procedure gets done. And there you see, based on what they have done up to that point, this patient has a 65% at 6 months to be healed. And that it happens in real time as the data is being fed. So really, this kind of work is based on some of the physics that we have done here at the University of Buffalo. Also, we have done a lot of work on hemodynamics and healing with devices and so forth and so on. But this work is technically appeared as a challenge that we have faced. We have done this many times for years in the lab, in animals and other in vitro or so. And then when we moved to the hospital, it didn't work. The patient heterogeneity, all the differences that we have seen into patients and so forth, have made our work or our prognosis tool mostly useless. You could go and flip a coin in the scenario and it would be on the same ballpark, right? So what we have thought about 6-7 years ago, we were at the conference and we saw this machine learning, deep learning, and we finally, it was like a light bulb moment. We said, you know what, we should use retrospective data, lots of retrospective data, and look into patterns into this data, using the same kind of concept that we had in order to look at this. So technically, these kind of drawings or live images that you see, we're putting like different filters in the eye of the AI, and it extracts patterns of flow that goes there. It tells us how fast fluid goes into an area, how long it stays into an area. What are the balance between going in and in this case into an aneurysm there. So these there give us at the pixel level to the point that human not always can perceive them. They are so subtle that even if with many years of experience, you might not be able to catch it. So when we feed this kind of data into a very large database, and then we train the models, we start having accuracy of about 80% to predict this on a regular basis. Now, it's not all rose, I would say, the life of doing these things. We have a lot of difficulties with different HIPAA compliance and so forth, security, how you upload the data, how do you keep track of all this patients that you're enrolling, and they're unfortunately, unlike other systems or that are ahead of opening the access to patient data in the US, we are really having a bottleneck. We're working with hundreds, maybe thousands of the patients to do this kind of stuff, when our competition has millions probably right now. So the effort from our side and at our levels right now, it is to establish the workflow, and especially how do we deal with the red tape in an ethical way in order for us to develop technologies that are targeting our population and because definitely if we train on a different kind of a population, this AI is not going to work for ours. So how do we have something that is representative for us? How do we have access to that data in order to do it? And at the same time, the people that are the gateholders of these data sets understand that we need to do this. Otherwise, somebody else is going to do it, and it's not going to be useful for us. So I could go and talk forever about also the other applications and things that we have in mind. We have in mind to multi-level AI, include demographics, lifestyles into these things, and really make it very targeted towards or patient-centric to include all this information, medications, and other things into this. So we are working into these models, and we think that this is the way to go. And hopefully, we're going to have, I don't know, RPH, what is the status right now? It's stuff like that. But I hope we have organizations like that that will allow us to congregate and solve different problems, vascular, cardiovascular, cancer, and so forth, so we can pull the data across the country and work on these things. So
I think that's fantastic. So Chip, what do you think the biggest challenges right now, like from like the data, is it more NIH grants, or is it basically just getting access to different hospitals? What do you think is the big challenge right now from an AI model? So your model, so we built the model, and it's taken a while, right? But you have data from hospitals, but how big does this have to get to be like a standard in the industry?
Right now, I think the first thing that we need to tackle is access to data, as you said. Then, just simply believing that you're going to put somehow a request, the data will magically be appearing from hospitals, that is something that is not going to happen. So we need to have interest groups, like we have a pretty large interest group into this kind of procedures, and for us to sit and aggregate. The other thing is you need experts to label this data and kind of like to have the correctly labeled data, and that is the experts are very busy because there are some neurosurgeons, there are some physicians, and so forth. So I think you can do it with graduate students and postdocs, and so if you train them well. So the next thing is curating this kind of data, and there are possibilities in there. AI that actually helps you curate the data to train other AIs. So there is a possibility into there. A thing that's been floating around, it is now a stock market of data. You put a request, and there is going to FDA has already, well, it had already, I don't know what is the status of that, but they had developed a bunch of like 12 kind of softwares or workflows in order to verify the data. It is free of artifacts. The data is not duplicate. The data is properly curated. So they have been working on tools that when you go and you claim that your data set is perfect or the data set is proper for AI training in medicine, they can check onto that. So there is this kind of software to check the data and then allow hospitals and other centers, when you put a request for a kind of data and so forth, to compete as a stock market technically. So this is what ARPA Age Index is about or was about. We do not know how this initiative is going to develop, but the call is still active. When we went into these meetings, and that was a concept that to create this stock market of data, because this stock market of data exists. It exists for stock market, for data transactions. It exists for credit card companies, and so you can actually put a request, and from this database you can pull it for a price. And that was the same idea, to have a healthcare database that is self-sustainable, technically, by companies like us that need data, pay a fee, and then they can use it, and it is regulated through the FDA kind of software. So hopefully the things will still go into the same direction. I know that there is a number of $500 billion around about the AI developments. So hopefully something will come out of it. And did that answer your question?
You did, and I just want, and we'll open up to the floor. I got another question for you. Is when can we see this in operating rooms? What do you think? What's your future, your crystal ball look like?
Well, if our plan was within a year and a half to be starting clinical trials on this. We all have heard about the NIH and all this issues happening right now. So we are sitting on the side and waiting for the waters to clear and see where we're going with it. But nonetheless, we're not the type of people that put all the eggs in one basket, and we're pursuing partnership with Siemens, with Medtronic. We have meetings with them and try to have an interest from the private or venture capitalists to come along. But if, let's say, the funds for a clinical trial become available, I would say 1 year, 2 years.
That's fantastic. You know, what's great about this is that it was invented here, by Chip and his team. He's got a great team of neurosurgeons, some of the top surgeons in the world.
Yes.
And there's a lot of practice up the street because, unfortunately, it does happen. And I was just happy to work with you for the last 2 years.
Yeah, this interface, this gentleman.
Well, it was definitely a lot of fun, but I tell you right now, we were really excited for this for the community of practice. But with that, we open up the floor. Have any questions? Go.
Yeah, I was wondering, first of all, thanks for coming. This is a very exciting project. Thank you. Yeah, thanks for coming. This sounds like a very exciting project. I was interested in finding out a little bit more of the details so that I can kind of predict. So I understand all the security risks and all the, all the paperwork and all the government regulations, but I was interested more in what exactly happened. So you have images, and then you have a machine learning model?
Yes.
And then,
I can get into the details. So now all the surgical suites have video cameras that track what's happening during the procedure. You can inject stuff like, can we replay that a little bit?
Yeah. I'll replay for you. Project contrast?
Yes. So you see images like that when that black stuff goes in and out.
Yep.
That is something that the surgeon injects in. And the way it flows, it is directly associated with blood flow. And the healing and the progress of the disease is associated with blood flow. But the phenomena is kind of complex for many reasons. First of all, it is a very complex flow that we have only kind of X-ray planner like a movie. We take a 3D phenomena and we make it a projection. So we're looking at pictures. So dynamic nature complex. Yet the physics isn't there. Subtle, but it's there. So now we parameterize these images that we're getting. We extract as much flow of information as we can through imaging biomarkers, and then we take those imaging biomarkers and put them into machine learning algorithm. So really, the video feed of the surgical suite is where the data is coming from in real time.
And how big is the data set?
So if we get into that, so it is so it's 1024 by 1024 images 16. So you're looking about 20, 30 frames. You're looking about 20 megabytes of data on one machine.
So are you using CCR or your own computers? And
We had actually been very lucky a few years ago, about 2 years, 6 or 7 years ago, we went to the Cummings Foundation, which is a local company. And at that time, we called the project development of an AI infrastructure at the Jacobs Studio at the Gates Masterpiece. And the only thing that we got from that was a big Dell server, or at that time it was 60 terabytes, and a DGX station from NVIDIA, which was one of the first of its kind. That was always a Cummings Foundation house. And this is all based on that. Still today, we're running our codes and training on those 4 GPUs that we got at that time. And once the model is trained, the inference, to make the prognosis, it's like 15 milliseconds on a normal CPU. You don't even need to have the training is one that takes a day, maybe. And everything else, once it's done, we load it on the AWS. We actually don't even need GPUs to run it on the AWS. We run it on CPUs.
was the cost savings from not solving on, so once we had the model, we basically sent that into the training model and saved us and saved the project a lot of, would you say, cost. So that's one of the biggest advantages of considering you're building your model is train it locally or train it in a private cloud and then leverage that. It's basically a black box at that point. There is some training, there's care and feeding, but I think that's a good strategy to reduce your overall cost.
My experience was debugging on cloud is not great. So always
Hi, Heather Campbell. You know me. I was just wondering, so when you say successful treatment, what treatment is actually happening here? Like, is it coiling? Is it clipping? And is this model specific for one treatment type only?
Yes. So we get again in the weeds, and now I'm going to bring the FDA into this. So technically, this is an aneurysm treated with a stent-like device. You put a tube in it and diverts the flow away. So when we went and presented this to FDA, first of all, they wrote a letter like they were very apprehensive about this technology because you kind of tell the doctor what to do next. So they consider this as a very high risk kind of AI technology. And then on top of it, they said for every type of surgery, if you use a different device, you need to have a different AI agent, and every single agent for every device needs to be FDA approved. But for the first device, you need to go with a de novo, which is a randomized clinical trial. That's why
you're now burdened with the cost of raw materials, cost of production, but you're doing it at the time of need. So it doesn't ride on the balance sheet. And it actually eliminates all the other non-value added costs, right? Warehousing, transportation, inventory management, all those sorts of things that add to the price, but don't add to the value of the object. And out of that, we decided, hey, what do we need to do in order to send that? In order to create an Amazon of these digital objects where we can point, click, and send out to the carrier room. And out of that, we came up with 3 integrities: data integrity, process integrity, and performance integrity. We had to solve for those 3 things, we thought, in order to send a part out to an aircraft carrier and have the commander out there go, yep, this is a good part, put it on the jet, go fly it. So assume the risk at the point of use, which is something not often done in the military. Somebody further up the chain of command is often assuming the risk, which as a commander on the ground, it bothers us, but again, something you deal with. Out of that, we went to a place called Techstars. We developed this marketplace, and once we developed the marketplace, we realized we'd spent a lot of money and created a failure. And we created a failure because the Boeings of the world weren't going to trust us with our IP, or the Lockheed Martins with IP for F-35 or something, unless we'd solved the data assurance piece. Unless we could ensure that nobody would be able to access their data. Is that a problem? Yes. You only have to look at the J6 or the J20, 2 of the latest Chinese airplanes out. They look exactly like our airplanes. And the Chinese brag about stealing our intellectual property because it's cheaper to steal, it's cheaper to steal or borrow than it is to actually develop yourself. I think perhaps you're maybe living in that environment, right? So what we set out to do was create an environment that we could, again, provide that data assurance. And I'll give you an idea why, and we'll go ahead and play this, hopefully a transition here. Let's see.
Not working?
How do you make it play from here?
Play.
Okay. Is it playing? All right, so you're going to see this video. This is 2015. Somebody through a fishing expedition was able to get into a company's network. And they're able to find a file. They're searching for a file now, and the file is going to be a propeller build file, a 3D print file, for a digi-drone. So they go in there, they find the digi-drone, they're going to download that file, or open it, and they're going to now manipulate that file. So subsurface, they're going to put voids in, and whereas you won't be able to see it when you're the third party manufacturing it, or the actual people who buy this eventually, you won't know. Then they re-upload it with the same file name. So the company's none the wiser. They don't know somebody's come in and trash their file. Now it gets pushed out to a third party for manufacturing because somebody has bought it on the other end. And that third party, they're going to get some instructions, they're going to get what it's supposed to look like, they're going to put it on the build plate, and they're going to manufacture it. Unbeknownst to them, that these voids are being manufactured right into the product. So you go, that's kind of scary. So then it gets sold, it's put on a drone, and once it takes off, the aerodynamic forces, because of the voids that are there, cause the propeller to fail and it crashes. Now, this is just a drone, a couple $100 perhaps, not an airplane, but it could be an airplane, it could be your car, it could be a bus, it could be a boat, it could be a windmill.
And I think that that is part of the game, is the nature of the beast there. So I'm going to talk about the artificial intelligence and machine learning and what comes out of it. Actually, I didn't come up with this title, but that's pretty much what I was going to talk about. And the first thing, though, I want to see where you are coming from, right? So I want to see your perspectives, fear, excitement, exhaustion. I've been using AI pretty much every day since it became public, and I was aware before the 2022 when it was released of GPT-2 and BERT and other models that have been used, but were not very effective, not at all. And it was really a bold move that they did when OpenAI released ChatGPT-4. So my first question, by the way, today in France they have the Artificial Intelligence AI Action Summit. So I'm considering ourselves to one of the satellite events for that summit. So to begin with, let me ask you one question here. So I'll try to keep my talk within the time allotted. Oh, that is, let's see if I can mute it, maybe. Yeah. So you're using your favorite language model, and somebody asks you, your kid, a friend, something that you're not familiar with. For instance, hey Dad, why do the latitudes of the Arctic Circle and Tropic of Cancer do not add up to exactly 90 degrees? You say, ha, I have AI, now I can handle this. So you ask ChatGPT-4 because you're not aware of the thinking model that is out. It says, well, the ChatGPT-4 tells you this, the kid goes to school and he gets a 0, this is all wrong. But it sounds pretty good, though. I mean, it sounded right. You know, it's dangerous because the circular deformation on Earth axial tilt, not a simple geometric division of the. See, I am not really very knowledgeable about geography, so I buy this. Well, the problem is you're not using AI properly. You cannot blame AI. This is a real life story. Somebody came to complain to me, look, I'm a physicist. I know how this works. This is not AI. But you may know physics, you do not know AI. Because you're not supposed to simply use it this way. In fact, if you would use ChatGPT 03 mini high, the response is 100% accurate. So getting back to here, I want to hear from you where you stand in this, in this battle. Let me get back to my, let's see, one second here. Where did it go? Window, here. Good. So, and here is what I want to hear from you, if you don't mind, share with us. So, where are you learning the code and math behind GenAI? For instance, this presentation there by Andrei Karpathy is only about 5 days old. By the way, if something is more than a week old, I don't watch it because it's already outdated. And actually, I try to watch anything that is 2 to 3 hours usually. So these guys, Matt Wolf and Matthew Berman, they put videos out every 5 hours, I think. I don't think they sleep. And so first of all, where are you learning how to decode and the math of generative AI is? Because you can do it. It's not really that difficult. And number two, what about the historical and academic context? So Fei-Fei Lin, a professor from Caltech and Stanford, has excellent videos. Yuval Harari, my favorite historian, he wrote the Homo Deus, Homo Sapiens. He just wrote a book, Nexus, History of Information, which is what we're talking, the revolution that we're going through now is about information, and people don't understand information. Jensen Huang, the guy from NVIDIA, has some really good videos as well. So where are you in the AI trends and advances? For instance, Matt Berman and Matt Wolf, they do a great job. There are many TED Talks, and one of them that I'm listening here is the scientist's new superpower. White papers. You can read white papers about this available all over the place. Actually, you should be reading white papers about your health from NIH. There are things that are released out there that will tell you whether eating something is good or bad for you. There is a lot of good stuff out there, and guess who's helping me read all that stuff? AI. And do you know the language models called requirements? Have you looked at tutorials? Have you looked at coding tools? Do you use Visual Studio Code, Python, HTML? And are you familiar with the cloud tools and the local tools that allow you to participate in this? Olama from Meta has an excellent platform where you can do things locally. Then Google, AWS, OpenAI also have a whole bunch of good things, and there are great code repositories. So tell me where you stand. Can I, ask you to participate and tell me what you think about all this? Where are you? Actually, just the other day, I'm teaching in a classroom, and there was somebody before me, and said, "Oh, why don't you stay? We're going to talk about AI." And then, you know what the answer was? That's rubbish. Okay, fine. And it was a professor of art, actually. So you get the most unusual responses from people, and so do you have the
Can I get a microphone?
Yeah. Let's get a microphone here.
Okay, any responses for Jacqueline? Anybody? Any quick? Go ahead.
I believe in third world countries, what I'm scared about is in third world countries, many people have been slaves for social media. Right? Coming into the future, AI might be so ahead of the humans. Many of the humans might be slaves of AI.
So you're the fear camp.
This is the fear category of my thing.
But what about any of those? Have you looked at any of these?
Yeah, I have gone to Android videos of LLMs.
Carpati videos, yes. So you are aware of the real danger. So you really know what's going on. I mean, if you don't go a little bit deeper, you can't really understand how amazing this all is.
Anyone else?
So for myself, AI was not something I was really considering, because I kind of think of AI as just, I wrote a program, and that program does a certain function. So the technology to me was just a bunch of knowledge, a bunch of information, a bunch of programs to produce a result. So as time went on, I'm struggling with how is AI going to help me. And I'm a Google Workspace administrator for about 100 domains, and everybody's got AI pushed down their throats with Gemini. So Gemini gets put into my system, and I'm like, you know what? I'm going to try to use this. So when I make long technical presentations, when I do things that I'm writing, things that are on my mind, I put that in Gemini and ask Gemini to rewrite it. So I found value in writing that stuff, making bullet points, things like that. But what is my real world practical use? Now, Gemini wasn't helpful, in my opinion, for me to answer somebody's email, which they would love you to do that. It's crazy. I can answer email myself. I don't find an application. So it's really acceptable. Now, the medical field and modeling and training AI, which is basically making code that looks at a certain things, is just find the differences in these pictures. And you look at 100,000 pictures, which I cannot do, and then tell me what the differences are. So that brings me to understanding this is the purpose, and being here to hear you guys speak about all this stuff brings all that together, and the understanding, the acceptance, and then say, okay, where do I go from here? So in my real world life, AI plays a small role, but I think in medical terms and things like that, it's going to play a much larger role, and that's my experience with AI.
Thanks. Yeah, by the way, when you have any text manipulated, right, you get a summary that works for you, how do you know that it's right?
You have to read everything.
Exactly, you read it.
You cannot trust it.
Yes.
It's long so much.
So yeah, that is, now if on the other hand, right, somebody tells you the mathematical algorithm is correct, do you need to prove it yourself, or can you trust the mathematical community?
Right now, we cannot trust anything.
Well, no, but right now our society is based on the fact that mathematicians, we have, I'm a mathematician by profession, when we write a theorem, that theorem is vetted so extensively that you can bet your life on it. I mean, really, the percentage of theorems in mathematics that are what behind engineering and physics are so vetted. I mean, there's no way you're going to get it wrong. So you can trust it.
So you're saying that the model that was used to train in mathematical equations, if you ask an equation.
No. What I'm saying is that AI, and we're gonna hopefully make this clear, and I'm gonna make it so clear that it's not gonna be me telling you, but you're realizing that the nature of mathematics is somehow a carbon copy of a quantitative left side of the brain, while AI is a right hand of the brain, right side brain calculator. It's a complete different nature. By definition, by nature, AI is like AI is like a virus that needs a human being to exist. Mathematics is like a bacteria. It has a life of its own. So without a man in the middle, I claim there is not going to be any AI. So they may make products that work, but by its own nature, AI needs a man in the middle. You need to check what you do.
So AI is like a virus. That's interesting. So I think that AI is an amazing tool, unique in the progression of humanity and the world. But I think that right now we barely understand the potential of this tool. People are using it for good and for bad. People are using it incidentally. Sometimes they don't even know what they're doing. So I think like any extremely powerful tool, we don't know how it's gonna evolve just yet, and what the benefit and what the cost for humanity might be. But I know that as for now, I watched in this AI gold rush, CEOs pushing to implement AI where it's needed and where it's not needed, being, I would say, irresponsible in the way they use it, not considering the risks and the costs.
I totally agree. I think that it was extremely brilliant move to transform this tool into a gold rush, and that they had to be a lot of lies and a lot of marketing, and like in California, every billboard had AI in it. Has AI in it since 2022. So but hopefully I will demystify a lot of it here, and then with that, people I think can have a more realistic view of what it is, what expectation is, and how to use it. So let me continue, so that hopefully we intertwine the conversation with what I'm going to be showing here. So academia and industry, there's, I think, very little doubt.
Consider, I think, ripe for innovation and also ripe for the attack vectors is the intersection or the convergence of technologies. So the intersection and convergence of AI and quantum is going to be a world that we can't even imagine. In the history of the world, one new technology has kind of always come on kind of alone by itself. But we're in an environment today where we have quantum coming on, we have AI coming on, we're shifting to this AR, VR environment, and we're doing everything like in space. So there's this huge collision of all these technologies, and out of it's going to come a world that's not recognizable to us. I truly believe that. So your threat vector is the same fertile ground as where your opportunity vector is going to be. So you're going to have to find a way to manage the technology we've talked about today for the good, and use also to defend against the bad, those threat vectors. And if I was in that position, that's what I'd be looking at. Way back in 2014, I made a model, and it was called the merge. And the merge simply is when technology meets market. That's the merge. And if you're on the left-hand side of the merge, that's new technologies. You're looking at, mega trends and all that sort of stuff. But I built a model to explain to somebody why Zuckerberg would pay $2.4 billion for his VR solution, because there wasn't a VR market yet. But the reason for him to jump in on the left side of the merge was he could control the speed of the market. He had funds and resources. He could accelerate the adoption and move it in, ideally. If you're on the right-hand side of the merge and you have resources and flexibility, you can respond and be number two to the market and so on. So if you think of Uber being on the left side and Lyft being on the right side, they're able to see what happened and then respond. Most big companies don't have resources. They have program money, like the government, and they run these long linear strategies that are 8, 7, 10 years long. F-35, 787 are good examples. They can't turn on a dime and be able to be close to the merge. So if I were in that position you mentioned, I'd be looking at the mega trends, what's out there, where those convergence zones are, and where the threat vectors are and opportunity vectors.
Great response. Now, Jacqueline, I think that the question for you is, what do you, if you were 20 years ago, Jacqueline, 20 years ago, and you had an ability to say, hey, this is my younger self, and you're able to see the future and say, what should I do to help my students be focused on what? And would it be generative AI? Would it be mathematics? Would it be psychology? Tell me about because you've lived a great life and...
Thank you. Well, that's a good question, because I had classmates in grad school that actually went into why don't we switch laptops? So that we don't...
Well, let me just pull it up.
Oh, that's it?
Yeah.
That was easy.
You're just making sure we stay awake.
That's right.
Sorry about that.
Actually, that was the trick here.
We did that on purpose.
Yeah, we did it on purpose. Actually, I had friends in grad school that went into neural networks and AI, and I honestly didn't think it was going anywhere. There was this ice age of AI for many, many years. It was going nowhere. And the thing that I would recommend anybody, the thing that now, as 20 years ago, learn something where you can go deep into it and you know for sure that what you're learning is true. That is, security is very important, blockchain is very important, and that the best place to find out is math. But you don't have to do the superficial math, you have to do the real math. That I only went into math because, as a language, it gave me certainty about the world, not because of the power it had to create tools to do war. So I think that and coding, from the number one, coding and math, they were what I thought was right back then. I would still recommend that.
Fantastic. So coding, and we'll tell everybody, kids and friends, math and coding. So Chip, a man that loves physics, he's a physicist as well, so a lot of mathematicians, a lot of math up here. I want to just ask you about the future of medicine. And the future of medicine, what does it look like in 10 years from now? So we went back 20 years. I don't know what it looks like in 10 years from now. What do you see from this generative AI or large models?
So the way I think it's going to go, it's more, I don't know, personal influenced by a view that is influenced by a lot of great people here in Buffalo area. So we are going to put a lot of the diagnostic and the medicine power into the hands of the patients. I think a lot of this wearable technology, with the AI, is going to move it in our homes. and we are going. If you want to be healthy and track what's happening to your body, whatever what changes are, how different diet it's influencing you, or how is your blood pressure changing, if you're watching different games or so, then you're going to be able to do it, and it's going to be very detailed, and it's going to, I think, combine with some of these machine learning algorithms. And more than that, we're going to have them explaining to the patient what's happening. Right now, in personal experience, I just got I don't know cancer or anything, but I got from a relative a diagnostic in the lab results and complains about headaches. I took a ChatGPT picture of it and asked it. It gave me which medicine it was happening which would cause this problem. And then I talked to a colleague of mine, a friend of mine who's at the National Cancer Institute. And I didn't tell her that I did that, but her prognosis matched exactly the one from ChatGPT. I mean, be careful about it, as we said, about some of these things, but I think the house full with sensors and the early detection of the disease, microphones that can hear the sounds of the lungs, and the blood sounds, and the heart, those are happening. You can actually, there's a startup here in Buffalo that you can listen to your own heart and is making a diagnostic on the AI. So I know John Kay, he was working on that in here. We're working on the same kind of thing, helmets that you can put on your head, or microphones you can put in your ear and listen to the sounds, so we can detect early if you're going to developing a plaque into your brain, or an aneurysm, or something else is in there. So, and train these sounds, because even you as a person, if you're at night and you're quiet and you're listening, you hear whooshing and sort of sounds. That are the sounds that the blood and the things are moving in your head, though we think there is information in there to extract this. This is just an example, but I think that's the next one of the things. And the other thing it is taking care of the elderly and robotics. I think that is coming in. We're 40% under employed in nursing, and also people or students going to nursing school. The number of those have decreased significantly also in the years. So we're heading towards a population aging and not enough people to take care of us. So I think the robotics and that will also become extremely important in the next couple of years.
Let me just add to that. I was at the CES conference this year, and adding to Chip's robotics position is that Korea has developed more robots for elderly care than any other country. And the reason is, and I believe China, because of the fact that there's issues with someone that be at home, there's not anyone to minister to the elderly parent, and the robot now can basically do most of the functions. And what the big deal is in the market is building models to train the robot. So now you can have a robot. Basically, you soiled yourself, it knows, because there's a specific model. They're looking for organizations to help. They're going to send you a robot, and potentially that's going to be a service. Train our robot, we'll give you X amount of dollars. So the big business now is train that robot, because these robots are basically little kids, right? They don't know about anything. They barely can walk, and then they'll get better and better. So I believe you're absolutely right. Medicine 3.0 is some kind of robot, but these folks in this room could help train. You train them at home to do a function, one function at a time. Before you know it, there'll be value to that. So great add to Medicine 3.0. So Jim, I'm gonna put your it's let's see, it's circa 2030, right? And we have robots in theater, right? So tell me about what that looks like, how to manage robots, human robots, or combat robots. So tell me how do we deal with that from a security perspective, and what does warfare look like in 2030?
All right, before I do that, when we meet the aliens, the common language will be math. That's why math.
And algebra.
But to your point, I did during the pandemic, we did this Web3 kind of battlefield of Web3. So you know, a lot of edge computing, right? It's going to be on the go. We talked a lot about, after the last Gulf War, that people were dying carrying water over land, right, with IDs and so on. So having autonomous vehicles was important. Having the UAV was important for extracting folks off the battlefield and so on. When you start to look and extend that thread further, if we say we're going to replace the man on the battlefield, we still have to decide whether or not who will make the tactical decisions for the robot. And if we're going to do that, we also have to then defend the robot, that data pipe that goes to the robot, so that it can, you know, do what we tell it to do and not be turned against us, and so on. So you're going to create an environment that's going to be more autonomous, much more automated. It's going to leverage, and especially the most harmful